Hello students, and welcome to the CompTIA Cloud+004 Exam Course brought to you by Third Level Technology. I am your instructor, Jim Herbie. In this episode, we're going to continue in Module 1 of the Objectives by discussing Section 1.4. Our topic is Cloud Storage. Let's begin. We're going to begin our episode of Cloud Storage Technologies by discussing the four categories of cloud storage. They are hot, warm, cold, and archive. Hot storage is cloud storage we need for data that is frequently accessed with low latency requirements. These will be all of the accessible data we need for our users in real time and that is frequently accessed by multiple users. The goal of hot storage is to have high performance and quick data retrieval. Some use cases for hot storage would be your transactional databases, as well as real-time applications and data processing. Hot storage will be your most expensive, but the benefit is the higher performance. Our second storage type is warm storage. Warm storage is going to be your intermediate data. This is data that is still accessed, but not quite as frequently, maybe not on a daily basis, but systems that might be accessed for maintenance and backups. Your warm storage will still have pretty low latency and have the ability to have reasonably quick retrieval. It's a balance of performance and cost. With warm storage, we frequently use this for our backups, our device maintenance, as well as accessing data on your intermediate storage. These could be things on a weekly, bi-weekly, or monthly basis. Your third storage type is cold storage. Cold storage is data that we want to still have active on our network, but is going to be rarely accessed. This may involve longer retrieval times because this may be data that is stored on an offline backup by the cloud service provider. We use cold storage frequently for large data volumes that we would use for long-term backups and disaster recovery. Many times your cold storage will be where you want to go if you need to do any type of replication, image files, or full data transfers in a ransomware situation. And your fourth data type is archive storage. Archive storage will be data that is at that moment offline from the network. These will be your historical data, compliance records, and things that will be the lowest cost per gigabyte because this is going to be storage that is also going to be offline from the cloud service provider's network. One drawback to archive storage is that if you have to access it, there's going to be a long wait time. You have to account for the CSP's time in retrieving your data from their archives and then making it available for your users over your internet network connection. Your archive storage will have your highest latency, and you also want to have your own records of where all of your archive storage is kept. Next, we're going to discuss your two common storage technologies used by your CSPs. These are solid-state drives and hard disk drives. A solid-state drive, or an SSD, is a storage device that uses flash and cell technology to store our data. In an SSD, you have no moving parts. Our SSDs to provide high-speed data access for applications such as our databases and our virtual environments. Your SSDs are the preferred option if you're running virtual machines. Your SSDs are typically more expensive, but that's due to the more advanced technology. Let's contrast that with a hard disk drive, or an HDD. Your hard disk drives are storage that use rotating disks that we call platters. And these platters use magnetism to store data on each individual disk. And we use a component called an actuator arm that will retrieve data when the user needs to from each individual platter disk. Hard disk drives are typically used in our modern environments for backups and bulk storage. Your hard disk drives also will require frequent replacement of components. Damage an actuator arm or a platter disk, you may need to replace the individual component, or in many cases, you have to replace the entire HDD itself. One advantage to both of these storage technologies is that they are hot swappable. What that means is that if there is some issue with a drive or a server at the cloud service provider's location, they can be replaced without having to take down the network. Next, we're going to discuss object storage. Object storage is a storage method that we use when we are using large volumes of data. With object storage, we take each individual data file and we assign it metadata. Metadata is when files receive unique identifiers that allow for easy identification and verification of our data. With object storage, we can use it for large data volumes and use our identifiers to create our own data set to be able to read and write to different files contained within the overall data volume. We use object storage when we want to provide redundancy and scalability for our media files and our storage backups. A second storage technique is block storage. Block storage is when data will be stored in fixed size blocks. We use block storage for structured data sets and our databases. Block storage has very low latency. That is because we have the same fixed size blocks, so it's very easy for the network to process these at very high throughput speeds. Block storage is used for our virtual environments, VMs and virtual technologies, as well as our high-performance applications and databases. A third cloud storage method is file storage. File storage is when our data set will be organized in a hierarchy at a file and directory level. We use file storage frequently when we have collaboration or network shares for data over the network. File storage is very accessible and compatible with almost all of your traditional operating systems. It's very useful for media files and collaboration projects, and file storage is also very user-friendly, familiar with the traditional folder and tree structure. And lastly, we want to discuss some implications related to performance and cost related to cloud storage. Some performance implications that you should be aware of include your different storage types and how they respond with our applications. Depending on the storage media that we are using, whether it's a solid-state drive or hard disk drive, we have to account for the latency requirements for our applications, as well as the storage requirements for an application on our storage devices itself for all of the files that are needed to run the software. Our solid-state drives will be the preferred method if we want to have very low latency and quick access. This will be our hot storage. And our cold storage can be assigned to hard disk drives because we don't need to have that quick access. We can account for some delay in being to access those data sets. Choosing the right storage type is very important, not only for applications, but also for the cost as well. You want to make sure that whatever needs that you have with your business can align with the overall budget that is assigned to your resources. And lastly, we want to discuss some of our cost implications. When you are using cloud storage, you are paying a cloud service provider a certain type of fee to use their services. With high performance storage, such as solid state drives and hot storage, that's going to be more expensive. That's due to the lower latency and quicker access. Some archival or cold storage, we can use hard disk drives, which will have a lower cost per gigabyte. We always want to balance the overall cost with the performance that is necessary for our users on the network. If we have any type of long-term or archival storage, we can always use that as a way to offset some costs by transferring our oldest data that is active on the network over to the archival storage. This is a good way to help balance not only your cost, but also your performance by removing data that is not frequently accessed. That will conclude our discussion of Section 1.4, Cloud Storage. In our next episode, we will move on to section 1.5 in the objectives, and our topic will be cloud native designs. We thank you again for following along in the episodes in the course, and wish you best of luck in your studies. Enjoy the rest of your day.